Okay, I will start. Good afternoon, everyone. Hello. I'd like to welcome you to this information session on the minor in space technologies. My name is Andreas Burg, and I'm the section director of electrical engineering. I'm opening this session because the minor in space technologies is formally attached to the electrical engineering section, but it's very important that it's by no means only for electrical engineering students. In fact, most of the students in the minor are actually from all kind of other sections, from mechanical, from materials, computer science, even physics and life science. So from all kind of sections. So it's open for everybody, and it's just a formal attachment to EE, but that has no impact on the content and of this minor. So space, of course, has always fascinated everybody, and it's a fascinating subject. But it's for sure more than a fascination, right? Everything we do on Earth today is supported by space. There are satellites for communication, for navigation, also for observing, for observation, for figuring out hazards in the environment, and making sure we have a sustainable planet for the future. So space is helping us everywhere. But you may ask, why do we do space in Switzerland? Because in Switzerland we don't launch rockets, at least not from our own soil. But Switzerland actually has traditions that are very well connected to space, precision and reliability, everything that's connected to watches and, the very traditional values of Switzerland is very important for space. And in fact, that's why companies worldwide trust us very much as a partner to deliver technologies for space. And that's why at EPFL, it was natural about 20 years ago to step into space and instantiate this minor in space technologies around 2005. And since then, this minor has grown a lot every year. Today, we are always in the top 3 sort of the minors in EPFL, so that's quite good. There are 34 minors at EPFL, so it's very successful minor. And it's successful because it doesn't only offer breadth with different courses ranging from, propulsion to robotics to Earth observation, spacecraft design, so many courses, but there are also many projects. There's a big project in the minor that you would do, and there are also many make projects like the rover and the rocket team and so on, which are tightly, attached to this minor. And of course, the results, we also see the results from this education. There have been several projects like the Swiss Cube, which was launched more than 10 years ago, I guess now, a lot more than 10 years ago now. The first, student-made satellite in space from Switzerland. Very prominent project, but also companies like ClearSpace that come out of Astrocast that came out of this minor in an indirect way with people that work there, but also the founders coming out of the minor. So it's been quite successful also in sparking innovation and the development in the future. So it's a great program to be in. And as you will see today, we will try to encourage you to participate. It's not only a nice program in terms of classes and project, but it also builds a community, and it really helps to, build a community, build enterprises, build companies, and contribute to this global effort, which is space with our values. That we do very well in Switzerland, making devices and things that work and that are precise and built for space. So. You will hear more about this in this 1 hour information session. And I would also like to, at this point, especially welcome Professor Claude Nicollier, who is here, who has always been very supportive of this program. He's been the first Swiss astronaut and the only Swiss astronaut, if I'm not mistaken, so far. So he's always been very supportive of the space minor and of the space education at EPFL. So I'm very happy that he's here today, and he will talk a little bit later to you. So with this short introduction, I will give the word to Emmanuelle David, who will tell you more about the program. And I wish you all a very nice afternoon.
Thank you, Andreas, for the nice words. My name is Emmanuelle David. I'm Executive Director at EPFL Space Center. EPFL Space Center, we are an interdisciplinary entity founded in 2003. And actually here we see a picture of Claude in space. There's just the thing. But it's fine. We are founded in 2003, and really with the goal to bridge the gap between technology and academia. And indeed, we support the section electrical engineering in the management of the minor in space technologies. This is why we're also here presenting, and we organize also the session today. So what is our Space Center activities? So our activities are around the 3 pillars of EPFL: education, research, and innovation. In terms of education, to mention the minor, but we also supervise and coach student projects and student associations related to space, and we will present them also after. In terms of research, we are here also to support space-related research within EPFL labs, and also supporting them in getting fundings, but we also have our own projects inside the center around 3 directions: the Sustainable Space Hub, so if you like space sustainability, you also should also come to us. Supporting also new technologies development, and also supporting space science and engineering. And finally, for innovation, our goal is also to support the transfer of the technologies with industry, but also to support your journey and your transfer after to industry when you want to you'll be looking for a job. So in that way, we support collaboration between EPFL labs and industry to do technology scouting. But we also host a network called Space Innovation Network with more than 45 Swiss entities from startup, established companies, and research organizations. And there we also try to make the link also between the students and the industry. So if you're also at some point looking for internship projects with industry players, you can always come to us at that point. So now we'll focus more on the education. Our aim to inspire and educate and boost the next generation of top talents in space engineering and science, which are you. And in that matter, I'll present a bit more now. We'll go more into technicalities of the minor. So a minor, what is it? Is during your master studies is a specialization. So you can be from any schools, any sections, and then you take the space technology minor. And in the minor, you need to complete 30 credits, which are 80 ECTS credits that are in the minor course. So you have around 29 courses, which are more than 100 ECTS. So you have definitely the choice. And Mathieu just after will present you the main courses in that area. And then you need to perform your minor in space semester project in that is related to space, and we offer every semester a lot of projects, but it could also be one of the projects that you perform within one of the space-related associations. Can it be the rocket team, the rover team, spacecraft team, but also SSA, the Callista. So there's tons of projects you can perform for semester project. So enrolled in terms of numbers, we have around 80 students, so it's total around the 2 semesters, like from M1 to M4. And you can see that throughout the years there's been an increase of interest of people attending the minor. So it's a lot of people and interested students. Yeah. And now I'll let then Mathieu go even more in the technical aspect and which are the courses that are offered in the minor.
Thank you. Good afternoon. She will be back right after me, so don't worry. So I'm Mathieu. I also followed this minor a few years back, and now I work at the EPFL Space Center with Emmanuelle. And I wanted to show this diagram. This is on our website. You can see the full list of classes that exist in this minor, but this is a proposed logic, especially if you want to focus on space systems, which ones to take first, and which ones we encourage you to take if you really focus on space systems. Have a look at it. It's quite useful, especially the first ones that I will talk about now a bit more in detail. They are here the 2 main courses that you need at the beginning of your space journey during your masters. The first one is given by Thibaut Künstler. He's actually the brave person who took over after Claude Nicollier was teaching this class for many years. But he's doing it very well, and he will teach you the fundamentals of space, the space environment, and also orbital mechanics, how an orbit works, because no, the spacecrafts don't fly as in Star Wars, and you need to understand that to be able to then do projects and have a also meaningful understanding of other space topics. And you see it's connected to many of the topics that are covered by the minor regarding propulsion, the history, spacecraft subsystems, etc. So it's one of the really main and fundamental bricks of this minor. The second one, spacecraft design and systems engineering. This one's a bit larger in size, 5 credits, taught by Emmanuelle, but also many external lecturers that we invite. This one is also fundamental to understand how to connect different subsystems together to make spacecraft or rockets or any type of system work with domain expertise in a big project. And this is especially useful along your masters, but also afterwards in your career. So we encourage you to take those 2 courses in your first semester of the masters, so that you have the content of those lectures available for then your next courses. There's also the project that Emmanuelle mentioned. So it's 12 credits, meaning you spend about a third of your time during one semester on one specific topic. And the topic can come from us, eSpace. We offer some topics every semester. You can have a look also on our website. But it can also come from the make teams or you yourself, if you find a professor that is willing to supervise your work. Then it has to be only related to space somehow. I mentioned here that co-supervisions are possible. We had already architecture students or life science students or any types of student that would do their projects. And sometimes we try to find the expertise from different professors to support the project. There is some also option for doing a project in your major. Can be, for instance, mechanical engineering. They have a project. And there you can also do it with a topic that is related to space if they accept it, depending on the conditions of the sections. And finally, the master thesis. This one is bigger. It's 30 credits, so you spend a full semester, full time on it. And this one too you can do on a project related to space. Here are a list of labs or topics and covered by labs. You can find them on our website as well. Those that usually collaborate with us on topics related to space at EPFL. Finally, also showing you what the Space Center is offering to students. Here you have a few pictures of our facilities, so places to work, to meet, to do your projects. And this is in PPH building, so you can access those facilities. We also support you to travel to conferences and events where you present your paper or your scientific work. And 2 new awards that were recently created. The first one sponsored by ClearSpace, the ClearSpace Prize. This one is for the best semester project in space sustainability. Actually, we awarded the first one this spring, and it will be handed a bit later on today. So it can be a nice motivation also to do one of the projects with us at the Space Center. And the second one is also brand new and will be awarded for the first time next year at the Magistral. It's an APCO Technologies Prize for the best average grade overall in the minor. That's it for me. I think I give you back the mic.
Yeah, thanks. I'll take this one. Yeah. Thanks. Just to go back on APCO, so APCO Technology, if you don't know, is a large company that develops space technologies and structures and ground support equipment that is based also in the canton. So it's also a great way also to be seen and for the future. So we're really happy also to have this prize, and it will be the first time this year. So people that are in masters, you can study hard to get your prize also. Now, to finish up on the other opportunities to learn about space at EPFL. So we are really lucky to have a lot of space-related associations. So I've put here, so there's Explore, the rocket team, the spacecraft team, but also Asclepios, they do analog mission for students, by students. Space at Your Service, they do outreach also on space. Callista, and actually now the Space Situational Awareness is the Astronomy Club from EPFL. And I'm sure they will be present also at the Week of Association. But this is really an amazing opportunity for you to learn, to test, to develop prototypes within really a great environment. I would say that those associations are extremely professional. So having an experience in those associations will really give you an advantage after when you will look for a job in a company, or even if you're for a PhD, if you want to test new things. And they are supported by the MAKE initiative, which is an innovative pedagogy that promotes, I would say, prototyping and project-based learning and interdisciplinarity. So in those teams, you will be working also with students from other sections, even from other universities. So I'll definitely encourage that, and it means in those associations we have more than 300-400 students that are working on space-related projects. And I would say this is really something unique at EPFL, to have this program, to have those opportunities, and that gives us also great reputation. Then if you really have even more time after you're working in the association and studying, we also have a few massive online courses on EDX. I think this is also interesting if you want to learn more. And sometimes we also organize 1 or like 2-3 seminars per semester when you can come and also learn from experts about a specific topic. So also after, if you think there are people you would like to hear about or topics, don't hesitate to come back to let us know. So to conclude, also I want to say that all the information are also on our website, so espace.epfl.ch. And if you go in education, you have EPFL minor in space technologies, the semester project, the online course students association. We also have Enhance Your Curriculum, where we put also possible summer schools that you would like to, that you could attend, or classes that are offered by the European Space Agency. They have an academy. So there we support, and so you can access also all those information. The website is really put up to date. Thank you, Candice, for this great job, because the information are really actual. So to conclude, to do a minor in space technologies, if you love space, even if you don't love, is really a great opportunity. What I want to say also is, if you do a minor in space technologies, you are in a MAKE association, and you even do your master thesis within a space-related lab or in an industry, the diploma you will have is really a diploma in space technologies, and will give you, will open you all the doors after for your future careers, and our alumni will tell you that. And this is really important, and EPFL Space Tech minors, alumni are really well appreciated by the community, should be in Switzerland or even outside Switzerland. So there is no doubt on that. So if then after you have questions, there's myself, Candice is there for the administrative aspect, Mathieu, Claude. Stefan also supervises some of the projects, so don't hesitate to come to us. Thank you very much. Yeah, I just wanted to mention also there's another date on October the 1st. There is the career the Center for Careers that organize also an event here with the European Space Agency. So it's the Forum Rolex. You will have Professor Nicollier again presenting, but also some people that are working at ESA, giving their testimony, and also Andrew Kane, who is also a coordinator from ESA, also helping out for people who want to enter ESA, so the European Space Agency, I guess. Who would like to work at the European Space Agency at some point here in the room? a few. So you will have to go to this event. That's good. And also note that they are really looking also for Swiss citizens that are sometimes underrepresented at the European Space Agency. So that's why they're also pushing during those events. So you can sign up. Here is the link for that. Okay, so I think now is the alumni lightning talk. So I'll let them. We have a special guest talk first. First, sorry, we have Claude, the special talk. Sorry. So I'll introduce you, Claude.
Yeah, good afternoon, everyone. Pleasure to be here, and I would like to thank the organizers of this session for inviting me to say a few words. I had an extraordinary privilege of going to space on 4 occasions in the 90s, and I can tell you it's a little bit of work, but it's an unbelievable privilege. And when I left the European Space Agency in 2007, I spent 25 years in Houston with my family, training on the space shuttle and performing 4 missions in the 90s. When I came back to Switzerland in 2007 after leaving ESA, I was offered a position as a professor here. And as mentioned before, I have been teaching one of the basic courses of the minor, Space Mission Design and Operations, for 15 years. And I have to say I brought a lot of what I had learned in Houston in training for spaceflight, in particular some aspects of orbital mechanics, like performing a rendezvous in low Earth orbit, how you do it. And there's quite a lot of orbital mechanics in this course, now taught by Thibaut Kunzer, who was one of my assistants. He gave a little bit of a different flavor in the course, but it still is a very basic course. And think about one situation, it's space mission design and operation. And the and operation was related to the fact that I had this wonderful opportunity to go into space. Think about this situation. You are spacewalking in front of the International Space Station, and you lose a tool with a velocity of 30 centimeters per second or 1 foot per second in the velocity vector direction. After 1 full orbit, an hour and a half later, the tool is 5 kilometers behind you. And this is relative orbital mechanics. And of course, this is very important if you perform a rendezvous, but also if you are spacewalking and you lose all kind of objects like tools or other things, or astronauts even. If you have an astronaut separating from the International Space Station 1 foot per second in the velocity vector direction, he or she will be 5 kilometers behind after 1 full orbit. So in the original course, I gave quite a lot of aspects, practical aspects of being in space. Thibaut Kunzer kept most of these concepts, but he added some of his own concepts, which are very interesting because he's working in the space department of the Swiss Army in Bern, and he's giving this course as a part-time activity, but with a lot of skill and talent. So I recommend very highly participation in the minor space technologies, and mainly the 2 basic courses, one of them given by Emmanuelle, as was mentioned before, which is more spacecraft design, but the course given by Thibaut Kunzer and formerly by myself, it's space mission design and operational aspect as well. I'll say a few words about Switzerland as a platform to be involved in space activities. Space Nation Switzerland. And Switzerland is positioning itself as a reliable partner and leader in key technologies and science and space, always aiming for excellence and innovation. It's a small country, but very productive in many areas of space technology, and excellence and innovation are 2 key factors in the space activities of Switzerland. Some past achievement of Switzerland in space, science and technology. Of course, we had Apollo 11, the night of the 20th to the 21st of July 1969, landing of the lunar module Eagle on the Sea of Tranquility, a picture of Buzz Aldrin, picture taken by Neil Armstrong, and an experiment coming from the University of Bern, the Solar Wind Collection Experiment, Professor Geis, University of Bern. And one of the very few scientific experiments that landed on the moon on that mission, because the main goal was to prove that people can go there and come back alive, and the science was secondary, but the experiment from the University of Bern was there, and the Swiss flag. It was not really. I did this one here. It was not. It was. It shows that very early in space programs, including humans space flights, Switzerland was present. And this picture was taken on my second space flight, which was the first servicing mission of Hubble in December 1993. I was the robot arm operator. I was not spacewalking, but these are two of my colleagues doing work on Hubble, which is here on that 5th out of 5 spacewalks. We changed the solar arrays. The main goal of the mission was to fix the optical problem, major optical problem that had been with us since the installation of Hubble on orbit in 1990. So it was 3.5 years later. And for the first 3.5 years, unfortunately, we could not do a lot of science because there was a major optical problem with Hubble. But we took advantage of our presence here to do some other work, typically change the solar array. And look at that work environment. This is unbelievable. And honestly, when I see this, it's a big wave of emotions. 600 kilometers above Australia here, this Antarctica in the background. One of my colleagues, Story Musgrave with tools here at the end of the robot arm, which I was operating, and Jeff Hoffman in the cargo bay fixing Hubble. And I put the Swiss flag here because the solar array deploy mechanism was designed and built by Contraves in Switzerland. It's one former company of RUAG, or a company in Zurich. So there's a piece of Switzerland here, and still is. In fact, again, the telescope was put on orbit in 1990, and 35 years later, we still have the same solar array deploy mechanism designed and constructed by Contraves, which became, as mentioned, RUAG and Beyond Gravity currently. So Switzerland was there. And I show these two pictures because just to illustrate the extraordinary beauty of the scenes in space. This was at the end of our work on the Hubble Space Telescope on the first servicing mission, December 93. And here you have an eclipse of the sun by the telescope. The sun is behind the telescope here, and we are moving in a direction outside of the screen. So we are flying over the terminator, limit day-night on the surface of the Earth. And of course, the terminator is moving toward the Earth horizon. And this is about 5 minutes later. The sun is still behind that part of the telescope, eclipse of the sun by the telescope. But of course, the sun is closer to the horizon, so you have a crescent of the Earth becoming thinner and thinner until sunset. Then everything becomes completely black after sunset. And I find these pictures so beautiful. Very high contrast, and the solar rays were like big golden foils, and it was really breathtaking beauty. It's science, but at the same time, it's the privilege of being there and seeing enormous amount of beauty. Now there's another spacecraft designed born in Switzerland, University of Bern and of Geneva, Cheops, characterizing exoplanet satellite. As you know, the study of exoplanets in addition to space debris, these are two major areas in astronomy and space activities in Switzerland. And Michel Mayor and Didier Queloz got the Nobel Prize in Physics in 2019 after discovering the first exoplanet in 1995. And then because of that familiarity and interest in exoplanets, these two, University of Bern and Geneva, thought about the idea of having a satellite to study in detail exoplanets, not discover new exoplanets, but study in detail the one that had been discovered. And that's a Swiss flag because the idea came from Switzerland. A lot of the construction came from Switzerland, but it was eventually an ESA spacecraft, still operating now. Now, major contributors to the Swiss space effort, you have the academia. Obviously, you have ETH in Zurich, and you have EPFL, including the Mine and Space Technologies. You have student associations that were already mentioned by Emmanuelle, Aris, Gruyere Space Program, PAVE, which is an output of the Gruyere Space Program team, Explore, designing robots, rovers, EPFL spacecraft team, Asclepios, they perform analog astronaut missions here on the surface of the Earth, but with the same thinking and same strategy and philosophy as doing a space mission. So between the academia and the student association, there's a lot of I would say energy going in space activities. Then you have the research and technology organization, which are sponsored by the Swiss Confederation, like CSCM in Neuchâtel, EMPA in Zurich, and PMOD in Davos, study of the sun. And you have the industries. I mean, these are all the elements of space activities in Switzerland. But again, we are interested especially in this one, but you have to know that all of these are present and a lot of dynamics in these, all of these elements of space activities in Switzerland. Now, this is Switzerland forever. That's a nice view of all of Switzerland from Geneva all the way to nearly St. Gallen here. And these are the traditional concept of Switzerland. Obviously, you have the mountain, you have the cows, the watches, you have the chocolate and the Swiss Army knife and the cheese. And this is Switzerland now and rising fast. These are a number of companies. This is not an exhaustive, but a number of companies very active in Switzerland, involved in space research and space technology. Now, this is a little more complete view of all of the companies in Switzerland. A lot of them are concentrated in the Lausanne area, but also Zurich and Neuchâtel. But all over Switzerland, including in Graubünden and in Ticino, you have companies involved in space activities. You have to know that. And I know that many of you may not desire to work in Switzerland, but go to Germany or France or Italy or maybe in the US. But Switzerland is a very active country in the field of space technology, space innovation, and space science. Now, as far as human spaceflight is concerned, I was the only Swiss astronaut chosen in the first group of ESA astronauts in 1978, so a long time ago, in a galaxy far away. Yeah. But anyway, a very privileged career and spending a lot of time in Houston training on the shuttle, flying these 4 missions. But now we have a new Swiss astronaut, Marco Sieber, a medical doctor from the University of Bern, selected in 2022 among 5 career astronauts, new career astronauts of ESA. And very talented. He's training a lot now, mainly in Houston, but also in other areas, because he will fly in the International Space Station, which involves 15 countries total. So he's traveling a lot, and he's very talented, very bright. I was watching his first quote-unquote spacewalk in the neutral buoyancy simulator in Houston. That was in August 2024, a little more than a year ago, and he was doing well, doing very well. That was his first dive, and it's quite an important step. You know, you have to prove that you are able to do the job. Then I went to the control room and took some pictures from video cameras in the pool. You see the Swiss flag on his shoulder, and he did quite well, and he's having a lot of success in his training and should be flying in space sometime in 2028 or 29, if things go well. There's a little bit of uncertainty now about the International Space Station program and the scientific program at NASA. We're a little bit dependent on the politics in the United States, but Sophie Adenau, who was a French woman, one of the 5 career astronauts selected at the same time as Marco Sieber, will fly next year to ISS. Raphaël Liégeois should be the second one. And there's still a little bit uncertainty about his flight. And Marco Sieber, we hope that before the end of the decade, he will get his space flight. I don't want to go into detail of that because that was covered a lot of detail previously. But anyway, you have all the information here on this site. And that's it. Best of luck for your future space adventures. It will be amazing, believe me.
Thank you, Claude, for this amazing talk. And now I'll like to give the floor to our 3 alumni giving lightning talks. I'm also pretty excited about what they will tell about the experience and what they've been up to now. So do we have a special order or?
Yes, we do.
So we start with...
It's the order that's here.
Okay, so Félicien Fiel, if you want to come first.
So good afternoon, everyone. Can you hear me fine? So I'm indeed an alumni, and I did the minor in space technologies about 10 years ago already. And time flies, not as fast as in space, but still. And so the key aspect of it for me is like interdisciplinarity, because so at the time I was doing my bachelor in physics, and the Space Center was still in the electrical engineering building, and then I moved to the Swiss Plasma Center over the road, and I remember like one special session where a staff of the Space Center that at the time introduced the different projects, and one especially caught my attention, which was like a plasma thrusters, of which I've never heard before. And this happened because he took a coffee with my now supervisor, Ivo Fourneau, at the Plasma Center, who so they chatted over coffee in front of the coffee machine about just potentially starting a space research activity on plasma thrusters, and I found that super exciting. So I did my semester project in this lab. I really loved it, the laboratory environments, the playing with tools and fancy equipment and all this. That's at the end of the project, I loved it so much that I decided to shift my interest from astrophysics to plasma physics, and I did my master on the same topic, looking at the feasibility of developing plasma thrusters for CubeSat applications. And so I'm like building it up. It's like actually then started a chain of events where I did apply for the ESA YGT program, so the Young Graduate Traineeship. And there was one topic. It's like there's like something about like 120 program, like topics you have to choose from, but you have to select one. And there was one about plasma propulsion for the Bepi Colombo mission. That's the ESA mission that is still on its way to Mercury. It's gonna arrive, I think, in a few months. I'm not so sure anymore. And so that was like a beautiful link between my master degree project thesis and this YGT traineeship. I did apply, and I was lucky enough to get it. So then I left Switzerland and went to the Netherlands to work at ESA for a year and a half, and that was like extremely exciting. I was just like really rocketed up into ESA, sharing the offices with people from the Bepi Colombo science project. So I was sharing all the meetings with all the lead of each subsystems, and in this position I was like meant to check the design of the plasma propulsion system of Bepi Colombo. And the Bepi Colombo is like what's something like a 3 to 4 billion euros mission, and so there was a bit of responsibility because I needed to tell my supervisor whether or not it was like properly designed or not, to ensure the lifetime of the thrusters that were very dependent for the mission to actually reach Mercury. And so I never heard back, but given it on its way to Mercury, I think it was actually like the yes was the right answer. And but yeah, that was like crazy to be just like, and the minor in space technology actually like gave me the tool, especially the class on space systems, because I was just like, I had to check all the subsystem interaction with the space propulsion system, and like this specific paper gave me like a lot of the tools that were essential for this job. And so at the end of that, I wanted to go back to research, to do a PhD in plasma physics. And my supervisor at ESA put me in touch with professors in Australia. And that led me to actually do a PhD in Australia and New Zealand, where I stayed for 5 years. I came back to Switzerland 2 years ago, and now I'm like a postdoctoral researcher at the Swiss Plasma Center again. So it's a long loop, but that was, in the end, all thanks to a coffee cup at EPFL, just over there. So, thank you.
Let me introduce you to Gloria, who graduated last year now, and she will be presenting also her experience as an alumni, a fresh alumni.
Thank you. Hello, everyone. My name is Gloria, and as Emmanuelle said, I graduated like only 2 months ago, actually, so it's all very fresh. And I did my bachelor's in microengineering and my master's in robotics because I really like having the interdisciplinary view of complex systems. And I have a passion for space technologies ever since I was very young, but basically it was even before I started getting interested in engineering. And so naturally I gravitated towards the space minor. And I'm not going to talk about all the courses that we had, but all of them were really amazing and kind of the reason also why I came at EPFL. But some notable moments were the space propulsion course, where we have to build a model rocket and then fire it. And I remember with my teammates firing it multiple times, failing, trying again until it actually launched and was recuperated by the parachute. So this was an amazing memory. And of course, the courses given by Professor Nicollier and Professor Fusier were also giving a lot of context into the complexity of space missions and all the different technicalities. So it was extremely interesting and really the highlight of my week. So now I will talk a little bit about the projects that I did in relationship with space technologies. And so the first one is actually my longest project, which was EPFL Explore, which I worked at for 3 years. And so this is a MAKE association where we're a team of around 60 students. And we are aiming to build a Mars rover and a drone for participating in the European Rover Challenge, which happens every year. So this is the 3rd iteration of our rover. And as you can see, it's very complex. It has a lot of different subsystems, but basically it's supposed to perform the same tasks as like the standard task of a Mars rover. So sampling, drilling, having a drone for exploration. So all of this taught me a lot on why I loved interdisciplinary projects so much. And then I worked on morphing robots for extreme environments navigation. So this, as you will see later, is kind of a pattern for me. I really love having these innovative designs for extreme environments. So what better extreme environment than space? So this specifically was performed for glacier exploration. And as you can see, this robot can morph between 2 different shapes. So first it has a rover configuration, which is stable for most terrains. And then for crevices, it can go into an elongated configuration. So all of this is done automatically through a magnetic lock. So this is the robot that I built. And then I had the amazing opportunity for my master's internship to go to NASA's Jet Propulsion Laboratory for 6 months. And so I did a project on the mid-air helicopter delivery. So this is done for the future iterations of the Mars helicopter. So you know Ingenuity, this is like the version 2.0, which is basically much bigger. It has a 5-meter diameter. And normally you would use a lander to transport the payload basically from the aeroshell to the surface of Mars. But this is extremely costly and very heavy. So the solution that was developed is to use a jetpack that is directly attached to the helicopter. And so all of this will be dropped from the aeroshell, and then around 200 meters of altitude, the jetpack will fire, which will decelerate the free fall of the helicopter until it reaches the surface of Mars. So I specifically worked on the TRL-5 test campaign for this. So this is basically unit testing in a relevant environment. And so I had the opportunity to go to NASA Ames to perform tests in their vacuum chamber. And so the video that you see on the right is actually in this vacuum chamber at Mars pressure. And so I was testing to measure basically the wind velocity that is generated by the thruster and how it will interact with the rotor of the helicopter to see if there's any disturbance that would be critical to the system. And last but not least, I did my master's thesis at Caltech, and I designed a multimodal morphing robot for asteroid surface exploration. So asteroids are extremely interesting because they have a very low gravitational field and density, which means basically that it's extremely complex to make anything navigate on it before it just goes into space. So a small impulsion will result in basically a catastrophe. So here is the design for the robot. This robot has two modes of locomotion. So it can either hop for long-distance traversals, and this is energy efficient, or it can rove for very small distances at a very low velocity for precision trajectory in order to go to its target point. So the wheels can morph in two different forms. So it can adjust its grip to the terrain as well as increasing the diameter of its wheels, and this is done to adjust the hopping distance and to control the turns of the robot. So as you can see here, it's the prototype that I developed, and on the bottom right is the test that I did at Caltech to move the robot around and test it. Yeah, it's a little bit of a long video, so. So thank you very much for your attention. So this has been an amazing experience, and honestly, it's all because of EPFL's eSpace Center, because they really supported me while I was applying for these positions with all the documentation, and I would not have been able to get there without them. And all of the courses that I did were really amazing, so if you have a passion for space, I think you really can't go wrong with this. Thank you.
Thank you, Gloria, for this amazing testimony. And now, last but not least, Alexandre will also tell you about his path and what he's doing now in space.
Hi. So I graduated in 2019, so electrical engineering with minor in space technologies. And now I'm working at just Innovation Park at Viasat, so one of those companies that was in the full map there as a system test engineer. And before that, I was also in another company, also at Innovation Park, Astrocast, that was also on the map there as also a test engineer. And those opportunities to actually work in a space telecommunication company, so Astrocast and Viasat above that, were only opportunities I could have gotten thanks to the minor in space technologies. And so one part of that was like having the system course, the spacecraft design course, learning all the different aspects. That was very valuable, and is now pretty much what I need to do as system test engineer at Viasat, understanding the different interfaces between all the subsystems and talking the mechanical engineer jargon, but also the RF engineer, the telecom engineer jargon, the software engineer jargon, and trying to make all those teams work together. That's something that all the interdisciplinary project, the MEG project, will teach you, but also the spacecraft mission design course also helped there. One thing I forgot to mention, I was also part of the EPFL rocket team there, and that definitely helped also with the interdisciplinary aspect of it. I don't think I've got even much else to say. Oh yes, I forgot to say one thing. One course that I would recommend is the sensor orientation course from Jan Skalud. I couldn't have taken as part of my electrical engineer background in master, but as the minor there, it allowed me to take this course, and then I ended up doing my master's thesis with this professor as well. And it taught me a lot about coordinate system, actually applying stuff I learned from Nicollier's course about the different coordinate system, like Earth reference, spacecraft reference system, all that. And that was quite valuable. And I really enjoyed that experience. So, yeah, that's it.
Thank you. Thank you so much for the three of you. So you can see that this minor is really interdisciplinary. So you had someone more with the physics background, robotics, and electrical engineering. All of them had amazing, I would say, career or beginning of a career, amazing experience in the US up to Australia, but also still here in Switzerland. So whatever person you are, just you want to stay here or travel the world, we will give you the opportunity to do such with EPFL Space Technology minor. So before we get to the networking and the food and the pizza, because this is, we know you came for the pizza, we'd like to do a award ceremony. So if Claude, you can come to the floor to give the award to our awardee, who's here. Come, yes.
Yeah, we have William Martin, who is getting this prize here, ClearSpace Prize, enabling the Souvenir Observatory for space debris observations. Are you going to say a few words about this? I'm going to give you the prize first, and then you can say a few words about it, okay? And my warmest congratulations.
Thank you. So, yes, if I can say a few words. First of all, thank you, Claude. Thank you, the selection committee, for this prize. And a special thank to Stefan, who was my supervisor during this project. He gave me precious advice and supported me along this project. It was a fantastic project where I have learned a lot of things. And actually, it was an opportunity to discover topics I wouldn't have had access to through the EPFL courses. And yes, if I have few words to say, I can recommend a semester project highly enough. It's a really valuable experience. You know that the semester project is elective, but it's worth about 12 credits. But do not hesitate. Just select a topic you like. There's a wide range of different topics, from associations, rocket team, explorer, etc., to many laboratories, such as the EPFL Space Center or Laboratory of Astrophysics. So yes, I recommend semester projects. If I quickly present my project, the aim was to overcome the lack of non-sidereal tracking for the telescope at the Geneva Observatory. This telescope is a 60-centimeter telescope mainly used for sidereal observations, which means planets, galaxies, quite slow objects. And the aim was to observe fast-moving objects in low Earth orbits, such as rocket bodies, dead satellites, etc. So I had to design a Python script based on orbital mechanics and dynamic mount commands. And basically, what the script what does it do? You give it as an input NORAD ID, which is a special number linked to a specific element orbiting the Earth. And what the script outputs is a specific rates. What are those rates? It's the angular velocities of the telescope axis. So if you enter an NORAD ID, the telescope pre-orients towards a specific meeting point in the sky, and when the meeting time has come, the tracking is enabled, and the satellites start to track the object in the sky. And the point was to continuously update those angular velocities, those rates. So we had solid results, I mean convincing results. We were able to observe objects in the sky during 30 seconds to a minute, but at some point it was diverging as it was an open loop control. And there was also hardware limitations such as latency. And I know that the students taking over the project for this semester, and I hope that he will be able to enhance this project, and from those data, scientists can extract useful data for space situational awareness. So yes, I had a great time working on this project, and thank you everybody for listening. Thank you for the prize committee and to Stefan. Thanks.
Okay, so to conclude, so congratulations again, William, for this prize. So ClearSpace is a EPFL Space Center spin-off that aims to remove space objects and space debris. They have one company here, and they're also based in Luxembourg and also in the UK. So it's also a great place also to look. They are always looking for students for projects, but also recruiting. So before we finish, I would like to thank you all for being here and for attending this session. I hope it was interesting. If you have any questions, you can come to us after during the networking event. So I'd like maybe, so there is Stefan from the Space Center, if you can just like show, so you can ask him questions. There is Mathieu also. Here, there's myself. There is Candice also, she's for the admin. I'd like to give a big thank you for Lucy and Joanna for organizing this amazing event. It's something we really wanted to do. Thank you also, Andreas, for being here and doing the introduction. So with that, I conclude, and the pizza will be waiting for you outside. Thank you very much.